discuss about the citrus. When an external deforming force is applied upon a solid, the configuration of the body is changed due to change in normal positions of the atoms and molecules which constitute that solid. Now, by that, an internal restoring force comes into play that tries to bring that solid back to its original configuration. Citrus is defined as that internal restoring force per unit area. So we can say citrus is equal to internal restoring force that comes into play to bring that body back to its normal configuration per unit area. So we can say that citrus is internal restoring force per unit area. If the body comes back to its original configuration, that means in case there is no permanent deformation or in case of no plastic behavior, this internal restoring force is exactly opposite to the external deforming force. In that case, we can equate the external deforming force and the internal restoring force. So we will come up for another equation of citrus, that is citrus is equal to external deforming force per unit area. Now, this equation can be used only and only if there is no permanent deformation in the body by the external deforming force, or in case of absence of plastic behavior. Now, the internal restoring force is a force, external deforming force is a force, so the units of citrus are Newton, and area has got meter square, Newton per meter square, or pascals. Now, going to the dimensions, we know that the force has got dimensions of mlt minus 2 and area has got dimensions of L square. That is, we have got the dimensions when this L square comes in the numerator, it becomes L minus 2, and L minus 2 plus 1 is L minus 1. So the dimensions of citrus are ml minus 1 t minus 2. Talking about the type of the citrus, we broadly discuss citrus in two types. One is normal citrus and another tangential citrus. In normal citrus, the deforming force is normal, and in the tangential citrus, the deforming force is tangential. Now, the normal citrus is classified as tensile citrus, compressive citrus, and hydraulic citrus. We will take them one by one. In tensile stress, as you can see, the deforming force is normal. This force pulls this cylinder both ways, causing an increase in its length. The actual length is L, the increase in length is delta L. Compressive stress, as you can see, the forces in this case are opposite to the tensile stress. It causes the elongation, so it causes the compression. That means a cylinder is pushed from top as well as bottom, causing decrease in length. That citrus is normal, so this is normal citrus as it causes compression, so that normal citrus is called as compressive citrus. Hydraulic citrus, this hydraulic citrus, in hydraulic citrus the deforming force is also normal, but it causes the change in volume without change in the shape. This is possible when a solid body is immersed in a fluid under high pressure, and under that high pressure the volume of the solid decreases without causing a change in the shape. That means it was a spherical solid of volume V. When under hydraulic stress there is a change in volume delta V, but the shape is spherical. So there is no change in shape but the change in volume. This is called as hydraulic citrus. In tangential citrus, we can see the force is tangential, not normal. This tangential citrus causes change in the shape of the body without changing its volume. If a box is resting on a surface, we apply a tangential force on it. When a tangential force is applied on it, the bottom remains there, but the top of the box changes its position in the direction of the force. This stress is called as tangential stress. As the stresses, normal stress, tensile, compressive, and hydraulic, and tangential stress, all are forms of stress. So the dimensions as well as the units are of stress. Thank you.